Hi everyone. The lesson is properties part 2, custom getters and setters. So this is part 2, so you have to make sure you look at part 1 of this lesson before this. These are the tools we will be using for this lecture and their references. It's very important for you to complete this prerequisite part 1 before you look into this lesson. You can find the link to this lesson in the description. You will be learning here about why do you really need getters and setter methods, declaring custom getters and setters, and usage of these setters for information hiding. As usual, it's going to be practical demonstrations. So let's look into the practical lesson now. So this is where we stopped in part 1. So in part 1, we got an employee class in part 1 lesson. We got 4 properties. We haven't done an implementation. So in the main method, we ended up in using the default getters and setters generated for the property. So these are the setters to set the data. These are the getters we use to get the data. Now let's look into this section about using custom getters and setters. Now the question is, why do we really need these getters and setters, right? Because you can easily do it with the dot notation, right? Without using these getters and setters. For example, you can, when you have these properties, you can straight away access them with the dot notation, right? So then the question is, when you can do with the dot notation, why do we think of using these setters and getters? There's a good reason for that, right? The reason for that is you can declare custom getters and setters, and that way, let's look into the let me take you into that way, right? You can control the usage of the properties, right? Especially you can use it for implementing things like information hiding, right? So let's look into the practical so you will understand that, right? Now let's say that we got a rule in this application telling the age cannot be more than 100. Let's say the person's age, we assume in this app that it cannot be a value more than 100, right? Or let's say it cannot be a value more than 60, for example. Let's say in this company, if there's a new employee, the new employee age should not be more than 60 years. Just assume like that. If you got a rule like that telling the age cannot be having a value more than 60, right? But that can happen as a mistake here. Let's say you create an employee called John and his age is 70, let's say. Now when you run this program, the program accepts the age of 70, and it accepts John and it prints the data. So the program accepts the value. But as I said little while ago, I just said, for example, in this program, the age cannot be more than 60, right? So employee age, you can't have an employee or having age more than 60 years. Now, how do you implement this rule, right? So how do you implement this concept to reject a value above 60, right? So for you to do that, you have to use custom getters and setters, meaning you have to customize the default getters and setters to do this. So now everyone is clear what we want to do. So let's see how we do it. So what you do is, when you got properties, let's say the age, you can go to the implementation and start implementing the getters and setters. Now as you know, the getter and setter, what are the getter and setter names? So the setter is set, the getter is just age, but the setter is set age. So I have to customize the setter, set age. So what you do is, in your implementation, you just start typing set age. Then you will see the signature of the setter. Now you can override this. In other words, you can customize this by selecting this and giving the method body implementation. So look at our previous lesson about declaring methods, right? So now declaring general methods. Now this is a setter method, right? So now this is how you customize the setter. So now, for example, if you want to reject incoming data, you can put a if condition here, and look at the parameter age. You can see the parameter is age. So if age is greater than 60, say if you want to reject it, then you can say ns log, right? And you can say the age cannot be more than 60, right? So let's put that. So I put a message in the age cannot have a value above 60, else only you will accept it. So if not, you want to accept the value, right? Because what happens otherwise is, now if I don't put the else, this is what will happen now. Okay, so it will reject any value above 60, right? So now if I go to the main method, right, I don't have to do any change. So when I say set age and run this program, see what happens, right? Okay, so it has not accepted the age, right? It has not accepted the age, though I gave age. Let's look once again. Okay, one small thing. Now it has not accepted, but I got a warning as well here, right? So I didn't see that earlier. What's this warning? It says writable atomic property age. What is atomic property? If you remember the previous lesson, I said when you declare a property, there are some default property attributes such as read, write. Similar to that, the default property attribute has a value called atomic as well. So what this says is writable atomic property age, because by default a property is atomic, it says cannot pair a synthesize getter with a user defined setter. So now about this synthesize getter and that one I will be discussing after this lesson, right? So but for now, when you see this error, writable atomic property cannot pair with a synthesize getter. So there's something called synthesizing, which I will talk, which is automatically applying and generating. That's what it really means in the auto. So with a user defined setter. So simply for now, what you have to do is, until I discuss about this synthesizing, what you have to do is, because it says the writable atomic property cannot pair a synthesize, so then you have to make it non-atomic for now, right? You really don't know what it is, but for now you have to make the age non-atomic for this, right? So you have to give this property for now, do it temporarily, you have to say it as non-atomic, right? For now, until I discuss what it is. So then if you go here, right, and let's compile this to see what's the end result. So now it says build succeeded, right? So now, so only change I did is I made the int non-atomic, because it said the atomic property cannot have that custom setter. Now with this, let's see what's happening here. So as you can see, it has rejected the value. It says age cannot have a value above 60, right? But the thing is, now if I put 40, which should be working, right? So if I run this, it has not rejected 40, so I'm not getting the rejection message, but still it has not assigned the age. The reason for that is, when you have a custom user defined setter, what you have to do is, you have to make sure that you accept the value and assign it as well. So for example, the age value you have to assign to the property. Your property is age, right? So you have to say property age, right? Now in this case, when I type age, I'm getting age in the first line, x, it's a variable, which is the parameter. Then I got a v, it's underscore age. So if you remember one of our previous lessons, in the first lesson about classes and objects, we said when you declare a property, by default it gets instance variables created. So I will discuss this after this in the next lesson, right? I will discuss this in the next lesson. But for now, you have to understand, when you declare a property, it will automatically synthesize and create an instance variable called underscore age. Now this we will be discussing in more detail after this lesson, right? So for example, if you got a property called age, internally it will automatically synthesize and create a instance variable for the property age, and that is it's going to be having an underscore in front of the property, which means it's going to be underscore age. So for that, I'm going to assign the incoming parameter age. Now, if you are confused about this, don't worry. I will explain it further in the next lesson, right? After this, right? But for now, what you have to understand is whenever you create a property, Objective-C will automatically create a corresponding instance variable for that particular instance, meaning for the instance for this particular object, right? Created out of this class. And that instance variable will have underscore in front of the property name. So which means if you got a property called age, the instance variable is underscore age. Then this property EMP number will also have an instance variable called underscore EMP number. This will have an instance variable called underscore name. This will have an instance variable called underscore salary. So this is going to be underscore age. That is why I had to put underscore age to refer to the property age, so that it assigns a value. So this age over here I'm referring is not this age. This age is the property. But over here when I say age, it's the parameter. It's referring to the closest score. So I'm getting the parameter and I'm assigning it to the property. But how I assign it to a property is I will be assigning it to the corresponding instance variable. So that is a standard theory, right? So I will make it more clear when I talk about synthesizing, etc., right? But now you got a custom setter. So now let's run and see this program, right? So when you run this program, as you see, it accepts the data and puts the value into the age. And if you give once again a larger value like say 90, it will reject the data, say cannot have a value of 60, and it will not assign. So this is a good example for you to understand why you need getters and setters. So especially that is because you can customize the setters, but you can't do this if you don't have if you don't know about getters and setters. For example, in this example, when you are directly assigning to the properties without getters and setters, in this case, if you want to assign 90, it accepts and there's no way of rejecting it, because you have not because if you want to reject this, you have to do it through the getters and setters. In fact, you have to do it through custom setters. So that is why sometimes you can use this dot notation, but if you need something like this, right, if you need something like this, like a validation, right, custom validation, then you have to use a custom setter. Now this is also known as information hiding in programming, right? So what I did was I used setters to implement the theory of information hiding, so, and data validation, right? So awesome. So with this you understood why you need custom getters and setters. Let's look what's next. So if you look at the developer docs, you can see now you know about accessor methods, getters and setters, right? And then you know about the dot syntax, so you can put a dot and access, or you can use the getters or setters. You saw both of them. Then this clearly says properties are backed by instance variables. So that's what I said. Properties are backed by instance variables. So if you got a property called EMP number, then there's an instance variable called underscore EMP number. If you got a property called age, there's an instance variable called underscore age, right? That's what I was referring here. So that's what this says. Properties are backed by instance variables. It says, if you read more about this, it says by default a read write property will be backed by an instance variable. So that's what I said. By default there is an instance variable, right? Once again, what it says is this: if you got a property called age, it's read write by default. So read write property age will have a instance variable called underscore age, right? So this is known as the default instance variable for the property. This default instance variable, which will be synthesized automatically. So it's happening automatically, right? An instance variable is a variable that exists and holds the value for the life of the object. What does that mean? So what is an instance variable? So what is the difference between a property and an instance variable? Okay, properties will control the accessibility for data, meaning you can give various attributes and control it, right? and properties is what you declare. So properties is what outside programs will deal with. Properties is what outside programs will deal with, right? Now, but internally, okay, when outside programs are accessing the properties through setters and getters, internally every property will have an instance variable. That instance variable will be kept throughout the life cycle of the object, right? That's what this says here. Instance variable exists and holds value for the life of the object. What does that mean? When you say life of the object, see, the object here is E1. So this E1 object's life is till the end of the program, or until you destroy that object. So until you destroy this object E1, or until the end of the program, this E1 object will keep that auto synthesize instance variables for all the properties of its class. Once again, I repeat, the instance variable or the object will keep all the automatically synthesize instance variables of the properties of this class until the end of the program, or until this object is destroyed. So what it in another word, what I mean is, when you create an object of a class, if that class has properties, then the theory is, for this object it will have the auto generated synthesized instance variables corresponding to all the properties. If there are 4 properties, there will be, say, 4 instance variables, and those 4 instance variables is dedicated for this object E1. In other words, what I mean is, if I create another object E2 here, this E2 will have its own instance variables, its own set of instance variables. So the instance variables which E1 has will be different to the instance variable which E2 has. Now in this case, E1 will have its auto generated synthesize instance variables. In this case, because there are 4 properties, E1 will have 4 instance variables. Then E2 will have its own set of instance variables, in again 4 instance variables. So that means for every property you define, the compiler will automatically synthesize and create instance variables, and each instance variable group is assigned for each object. So E1 will have its own instance set of instance variables, in this case 4 instance variables, and E2 will have its own set of instance variables. So this is how in the memory it will keep these properties, the data for the properties separately for each object, because each object will have the auto synthesize instance variables. So that is the theory, and that is, those automatically generated synthesized instance variables will have underscore in front of the property name. So when you are accessing in the program, you will have to refer them as underscore h. So when you say underscore h, it refers to the instance variable, and E1 will have its own underscore h, E2 will have its own underscore h. So I think it's clear to you. It's very important for you to understand this difference, right? So let's move forward now. So if you look here, that's what it says. So if you got, for example, some string, right, and then you will have underscore strings. That's what it says. For example, if you look here, an instance variable exists all for the life of the object. I explained to you now. The memory for the instance variable is allocated when the object is first created. So the memory for the instance variable is allocated when the object is first created. So when you create the object over here, that is where the memory for these instances variables are allocated, right? Awesome. So for example, it will have an underscore prefix. See, that's what I said. For a property first name, the synthesized instance variable will always be underscore, having underscore in front, right? So it's, if it's first name, it's underscore first name, likewise, right? And then from your code, from inside the methods, minus means instance methods, from inside the instance methods, you can refer to this instance variable which is auto generated, right? Okay, in this example, my string is a local variable, which is, can be like here, my string in this example is a local variable, and underscore some string is an instance variable. So now you know, when you see underscore some, meaning something like this. So if you see, when now you know, when you say underscore it, you know that it's an instance variable, right? In general, you should use accessor method or dot syntax for property access, even if, so let's read that part, something important here. Let's read that. Now this says, for some reason, if you want to directly access the property, you have to say self dot, right? So it says, see, in general, this is something extra for what you have learned now. Look at this. In general, you should use accessor methods or dot syntax for property access, even if you are accessing an object's property from within its own implementation. So even within your own implementation, meaning within your own class, if you want to access the properties, you have to use either the dot notation or the uh, accessor methods, right? Accessor methods or the dot notation. In that case, you will use self. So if you want to directly access the property, you will say self dot whatever the property name, or you will use the setters and getters. So what it means is something like this, right? So for example, instead of this, if you want to refer to the property directly, you can say self dot age. Now in that case, you don't have to say underscore, because now you are directly referring to the property, and you can say age, right? So this works. If not, the other way is you directly use the setter, right? So you will say you will access the setter method. You will say self dot set age. You use the setter method and pass the age. So all three of them are correct, but either one can be used, and we will be using it in one of these in different situations. But now you know that for this case, either you can assign it to the synthesize instance variable, or either you can assign it using the dot notation, or either you can assign this parameter in using the setter. So either three of them will be working. But the most important thing here is you learn that properties are backed by instance variables, and they are automatically synthesized, right? They are auto synthesized. That's what you learn here in this section, right? Most properties are backed by instance variables. So this is something very, very important for you to understand, right? So let's see what's next, right? Let's move into the next part now. So let's look at this. So we did the practical demonstrations, and you learn some important things. You learn about all this, and especially you learn about why you need getters and setters, and declaring custom getters and setters, and using it for information hiding and validations. And also you learn about properties are backed by instance variables, which are automatically synthesized by the compiler, and the theory behind this. So you can find the link to download the source code in the description section. We use Apple Developer Docs, and have a look at the next lesson to complete this app. Also have a look at our other video. So we are very excited to see you in our next lesson. See you in our next lesson.